dive into is functions and statistics. And what you're going to notice is that there's a lot of overlap with mean, median, mode, which we did recently, functions, ratios, and probability. So they kind of all come together to have us analyze data specifically out of graphs and tables. This is a very good example to begin our study of functions and statistics, because there are so many different ways that the SAT or College Board could ask you about this single context. And here we have a scatter plot, and it's a grocery store selling pints of raspberries, and they set the price per pint each week, and it represents 19 different weeks. So the first thing that they could ask you is, according to the line of best fit, how many pints of raspberries would the grocery store be predicted to sell in a week when the price of raspberries is $4.50 per pint? And this is, if we look at the graph, our price per pint is on the x-axis. So using the equation that we're given, 233 minus 32x, we could plug in 4x and we get y equals 233. 32 times this $4.50, which when we multiply that out, we get a total number of 89 pints. So that's one thing that they could ask you. The next, for how many of the 19 weeks was the number of pints of raspberries sold greater than the number of predicted by the line of best fit, which is this line in the graph. So if these dots represent the number of pints sold, what we want to do is we just want to go in and count the number of dots that are above that line, where they sold more than the predicted value. So if I go in and count 1, 2, 3, 4, 5, 6, 7, 8, the answer would be 8. So for out of these 19 points, 8 of them are above the line of best fit. Okay. Moving on. Part C. What is the best interpretation of the slope of the line of best fit in this context? And on the SAT, this question would be followed by a multiple choice question. So the slope of the line best fit is, if we look at y equals mx plus b, the slope is negative 32. And this means that the correct answer would state that each dollar that the price of a pint of raspberry increases, the store is predicted to sell 32 fewer pints of raspberries. And then lastly, what is the best interpretation of the y-intercept of the line of best fit in this context? Now, one thing to really look for, like the College Board, they do try to trick you. The bottom left-hand corner of this graph is not 0, 0. It's 1.570. Therefore, we have to keep that in mind. So according to this model, the y-intercept, that if the store sold $0 per pint, that means that they're giving away these raspberries for free. 233 people would be expected to get free raspberries, which is not realistic. And then if we continue this graph, eventually it's going to go beneath the x-axis, which would mean that as the price approaches $7 or $8, that negative people are buying raspberries, which really doesn't make sense. So for this model, what it tells us is that we really can only look at data when it costs between $2 and $5. Okay, so the next problem, we have Maria walking, jogging, and running for a total of 60 minutes. And this graph shows her speed during the 60 minutes. We want to know which segment of the graph represents times where Maria's speed is the greatest. First thing I want to do, since the y-axis shows us speed, I want to find where on this graph the speed is the greatest. If we go higher on the y-axis, the speed's greater. Therefore, this segment here is the greatest. So I want to go and see if that's an answer choice. And yep, this is about 19.8 to 34.8. So this correct answer is definitely B. So it's just the highest part of the graph. And what choice A would represent is that Maria's speed's increasing from 6 to 8 miles an hour. Choice C would represent how the speed is decreasing from 8 to 6, and so on. At the beginning of the video, I did mention that there's a lot of overlap between ratios and functions and statistics. So here, if you read the problem, we have security manager at the store is estimating the number of shoplifters and the people who do not attempt to shop. And according to the manager's estimates, if the alarm sounds for a customer, what is the probability that a customer did not attempt to shoplift? Now, out of the time, let me get a marker, out of the time that the alarm sounds, there are 56 total times or attempts. And out of these times, 35 did not attempt to shoplift. So we're going to create a ratio, 35 over 56, and that's going to be equal to 0.625, thus making its cutoff, but take my word for it, choice D correctly. Let me add that in. Here we have a data plot or dot plot showing the distributions of scores on a current event quiz for two classes of 24 students each. We want to know which is true about the standard deviations. In Class A, the mean score is somewhere between 3 and 4. Because the large majority of the scores are 3 and 4, with only a few scores at 0, 2, or 5. In Class B, the mean score is 2.5, because these are all evenly distributed across possible scores, with many scores that are not so close to the mean. So since Class A is more clustered around the mean, the standard deviation in Class A is going to be smaller, meaning that choice A is going to be correct.